Hi everyone. So in this video, I'm going to show you the graphs of the three trig functions we would have studied this year. This video will not really do it justice in the sense that in class and with more time, we would have studied how to find the rule, we would have studied how to draw the graph. But I think in terms of getting ready for next year, I want you to at least be able to recognize these graphs. Okay, so we're not going to do word problems, we're not going to be finding the rule. But for this video, in this video, I just want you to get accustomed with what these graphs look like. So right here, I have a little animation. So what I'm trying to show you here is that the sine and cosine functions, the relationship between an angle in radians and its respective sine or cosine. Okay, so the green here is the trigonometric point as it goes around the unit circle. And the reason the functions are periodic, which means they oscillate between a maximum and a minimum, is because the values of sine and cos don't go lower than -1 and don't go higher than 1. Okay, so that explains the shape of the sine and the cosine function. So they should look, there's something similar about them. So I'm going to show you here. The sine and the cosine function are both considered to be sinusoidal. Okay, so if I drew this graph here, something like this is both the sine and the cosine function. Okay, so I'll explain that in a few more minutes. But just if you just saw this function here, you wouldn't be able to say, oh, that for sure that's sine, for sure that's cosine. This is a sinusoidal function, which can be considered both a sine function and a cosine function. Okay, so let me show you the similarities. So first of all, the one relationship that I want you to realize is that the blue here is the sine function. This here is the sine function, so sine of x. And the red is the cosine function. And what this is saying, right? So the sine of an angle in radians plus pi over 2 will give you the cosine of that angle. That's called the horizontal phase shift. So if we look at our graph, this is saying that the sine function, which is the red, which is the red here, always catches up. So let's say this is right, this here is the point 0, 1 in the cosine. This is the point pi over 2, 1. So the sine will always catch up to the value after pi over 2 radians. So that's what this is saying. This is the phase shift. Okay, it's always, the values are always pi over 2 radians apart. Okay, so this is what this means here. So for example, if I'll just do this example here. If the cosine, if I look at the cosine of pi, the cosine of pi is cosine pi -1. Okay? The cosine of pi minus pi over 2 will give you the sine of pi. Oh, sorry, I started in the wrong order. Okay, so the cosine of pi minus pi over 2, the cosine of pi over 2 should equal the sine of pi. Let's see if that's true. The cosine of pi over 2, which is right here, should equal the sine of pi. Yes. Okay, so this is, I was going to start another example, so don't worry about that. Okay, so that's what this is saying here. So I'm going to keep going. I basically want to show you if they both look the same, then how can we tell, or how can we call it a sine function or a cosine function? It's all in what we call the cycle. This is what we call one cycle of the basic sine function, which means you're going around the unit circle once and you're graphing all the points. Okay, so that's why the highest you can go is 1 and the lowest you can go is -1. So I know the unit circle has the exact values. This is considered one cycle of the sine function. Now, if it's transformed, right? If it was transformed, the function can also look something like this, or I should say one cycle. So one cycle is a peak, what I call a peak. So the peak and the valley. But if it's transformed with parameters, which we're not going to get into too much here, it can also look something like this. This is still considered one cycle of the sine function. Or it can be very slow, and this is considered one cycle of the sine function. Okay, so that's what I want you to understand. So a cycle is the design. This is the cycle. Okay, the cycle is the peak and the valley. The period, so of the basic, how long does it take to go around to complete one turn? 2 pi. So the period, if it's not transformed, is 2 pi. But the period can be anything. So let's say, for example, I'll just make up the values here. Let's say this is 0, and this is 1 unit. It means that the period of this function is 1. Okay, so we would have done problems with time. It could have been 1 hour. It would take 1 hour for something to do a complete rotation. But the period can also be much longer. So let's say this period is 24 hours. The period is how long it takes for the cycle to complete. Okay, so I know it's a lot of information here. I just want you to recognize the shape. So the shape, the sine function, the cycle is the peak and the valley. Just a little bit more terminology. This is the amplitude. The amplitude is the height of the peak or the depth of the valley. So the amplitude here, the amplitude would be 1. Okay, that's the amplitude. The cosine function, okay, so remember, the cosine function, the cycle is a little bit different. So what I was going to say, so remember before, so this is a sinusoidal function, okay? So this here is a sinusoidal function. Is it sine or cosine? It's both. If you're going to find the rule, and we're not finding the rule right now, but let's say if you were finding the rule and you would use this as your starting point, so this should look familiar. If you would use this as your starting point, peak and valley, then you would consider the function in terms of sine. But if you were going to use this as your starting point, then you would consider the function, you would find the rule of the function in cosine. Okay, so a sinusoidal function, that wavy curve, can be described using sine or cosine. It would all depend on which would be your starting point. So if I get back to cosine here, this is considered one cycle of the cosine function. Okay, it starts at a maximum, it goes to the minimum, it goes back to the maximum. Okay, so there's a lot of other details, but I just wanted you to at least be familiar with what one cycle looks like. So let me just repeat. Sine function, a cycle, a design of the sine function, oops, I wanted to use red, is peak, valley. Okay, I can transform it. It can be really wide, really narrow. So here, I'll do a few more. I can do much higher, peak, valley. This is also sine function. Or I can do peak, valley. Cosine function is a little bit different. It's, I don't know if you want to call it like a fancy U or, right? That's what one cycle of the cosine function looks like. Or actually, if we start to manipulate negatives, we transform, it can also look something like this, the opposite. Okay, that's one cycle of the cosine function. Together, right, if they're repeating, they would make a sinusoidal function. So, even though there's sine in it, this function can be described, right? If we look at it here, if someone says, okay, I'm going to use, it can also be valley first and then peak. So someone can describe this as a sine function, or someone can say, no, I'm going to use this as my starting point and cosine function. Okay, now, this is just a basic overview of what these functions look like. But very, very important is the period. Okay, the period is how long it takes for the drawing to complete. Okay, for one full design, that would be the period. So let's say if it's a Ferris wheel that was turning, if a Ferris wheel was turning, right? Someone gets on the Ferris wheel, a full turn of the Ferris wheel, let's say 25 seconds, the period would be 25 seconds. So we're not going to be drawing these functions too much in this short period of time that we have. We're going to be solving, but I at least wanted you to have an idea of what these functions look like. And then we have the tangent function. So the tangent function, a little bit different. The tangent function, so this is one I used Desmos for that. I just want to show you actually the tangent function. I won't put any values here. Actually is a series of curves with many vertical asymptotes. Okay, so that's Desmos doesn't graph like that. So I just want to show you so you can recognize it. This is one example of a tangent function. Okay, just wanted you to be able to recognize that. So that's a tangent function. What did I want to say? The asymptotes, the reason for the asymptotes is there are values of tan that are undefined. Where are the values of tan that are undefined? So here we have, so this is 0, 1 over 0, 1 and 0. This is 0, 1. This is -1, 0. And this is 0, -1. Tan is sine over cosine. So tan is undefined, right? If you try to find the tan of pi over 2 or 3 pi over 2, it doesn't exist. Okay, so tangent, next year in calculus, you'll see that tangent is actually related to slope. So I'm going to remind you that tan is sine over cosine, right? Which is like rise over run. So really, it's like you're finding the slope of the radius at this point. Okay, so not at that point. Sorry, you're finding the slope of the radius. So that being said, the reason why we have these asymptotes is because if you're studying the tan values, right, the slope of the hypotenuse, let's say we call the hypotenuse, is getting steeper and steeper and steeper and steeper. So we're going there. Then it's undefined, and then it starts the values start over, undefined, the values start over. So that's what's happening here. So we have a negative slope, then it changes, we have a positive slope, undefined, negative slope, and so on. Okay, so again, this is just a really quick overview